All right. Hello, my name is Gwendolyn Espy, and I'm an applications engineer at OutBack. And we also have Ian McCluskey, who is a product manager for OutBack Power, also joining us, and he'll be joining us vocally at the end. But we both would like to welcome you all to this webinar about the 2017 National Electric Code Rapid Shutdown requirements that technically should be in effect in January of 2019. However, not all locations have implemented it, but that's what we'll be talking about today. So in part of that, we'll be talking about OutBack solutions per the application and code cycle. We'll do an overview of the differences between NEC 2014 and 2017. We'll also be talking about OutBack products and how they communicate during a rapid shutdown event. And then finally, we'll be doing some examples of NEC 2017 solutions with OutBack systems. So this webinar will be about 45 minutes long. Everyone will be muted throughout the webinar. However, you can type your questions during the webinar through the questions box, which some of you have already done when we did the sound check. So thank you for that. At the end of this webinar, we're going to do a Q&A on questions that are related to this topic, which is NEC 2017 Rapid Shutdown. So let's get started. Let me just check something real quick. Okay. All right, so today we're going to review the 2017 Rapid Shutdown updates. Then we're going to do the different solutions for each application or code cycle. And finally, we're going to discuss the Rapid Shutdown communications. Like I said, we're going to talk about how our products communicate during a Rapid Shutdown event. And this will help you better understand how to incorporate third-party products. And then lastly, we're going to do some examples of NEC 2017 solutions with OutBack products. Also to note, I think I've dropped a handout, a PDF handout on the flowchart that we'll be reviewing later. That will come in handy when you're deciding what solution might be best for your application, just to let you know. All right, so first we're going to go over the 2014 rapid shutdown requirements. I won't try to go into the all of the details, but essentially the requirement is for controlled conductors should apply only to PV systems conductors that are more than 5 feet in length inside a building or more than 10 feet from a PV array. Controlled conductors shall be limited to no more 30 volts and 240 volt amperes within 30 seconds of rapid shutdown initiation. The voltage and power should be measured between any two conductors, between any conductor and ground. And the rapid shutdown initiation method should be labeled. And so essentially here we have, is that right? Okay, well, we have a boundary. We have an array boundary, and essentially the conductors inside the array boundary do not have to be controlled. It's the conductors outside of the array boundary that have to be controlled. So these conductors inside, this per NEC 2014, should be or don't have to be controlled. So it's all of these conductors that are in red, and it has to be within 30 volts in 30 seconds. So here for us, this is normally our combiner box. Our ICS Plus solution is our solution for the NEC 2014. Okay, so this changes with NEC 2017. So the array boundary changes to a 1 foot array boundary. And not only do the conductors outside of the array boundary have to be controlled, but also the conductors within the array boundary. So now not only do we have a narrowed array boundary, but now we have different requirements for the conductors outside of the array boundary and inside the array boundary. So within the array boundary, we have the requirement would be 80 volts, has to be less than 80 volts within 30 seconds. And then outside of the array boundary, which is indicated in these red conductors, it'd be less than 30 volts in 30 seconds. So this is the summary of what the NEC 2017 kind of a figure. I'm sure most of you are familiar with this. I just wanted to quickly review it. And so this is what essentially technically per NEC 2017 is in effect January 2019. However, not all locations or states have enforced this yet. but it's good to know what's coming if your location is one of those places. All right, so for as a summary, between 2014, so PV system circuits on or in buildings more than 10 feet out from the array boundary must be controlled to 30 volts and 240 volt amperes in less than 10 seconds. So this is the main part of the NEC 2014 that changes. So this left many gaps and uncertainties. So what is a PV system circuit? There was some uncertainty of what the definition of that was, and I think that became clear in NEC 2017. They cleared that up. And originally there was a 10-second requirement that conflicted with the ride-through requirements, so they later changed that to a 30-second. So we have NEC 2017. So like I mentioned, we have a narrow 1-foot array boundary. There's now separate requirements for the outside and inside the array boundary. Outside of the array boundary must be less than 30 volts at 30 seconds after shutdown initiation. This is the challenging portion of the code, and that's the inside of the array boundary. So according to NEC 2017, there's one of 3 options here when it comes to inside the array boundary. The first one is conformance, so you can get a listed rapid shutdown array. The second one is performance, so you can limit the voltage of conductors less than 80 volts. And there's construction, no exposed metal or conductors within 8 feet of the array. So these are the 3 different options that you can choose. You don't have to do all 3, you just have to do one of them in order to comply within the array boundary requirements. So when we talk about the performance part, which is the second one, this is what we all think of when we call on module level rapid shutdown. The requirement, the NEC 2017 and rapid shutdown requirements doesn't necessarily mean module level rapid shutdown, but that's what most people talk about. You do have 3 different options, but for right now, I think this is the one that's most available for us. So that's what people talk about mostly. All right. So what is OutBack doing about this? So we have products available now that address NEC 2014 and NEC 2017, and we are continuing to work with other companies to check if their solutions work with our products, and we'll talk more about that later. So with NEC 2017 rapid shutdown, like we talked about, there are inside and outside array requirements. Module level devices are available now that have been tested with OutBack products, include products from Tigo and IMO. So with the Tigo, we have the TS4-R-S, the FM80, FM100, and SkyBox all have been tested, and we're testing the FM100 and SkyBox with other Tigo models. We've also completed testing with the IMOFire Raptor product, and we're continuing to test with other third parties to make sure that installers and the installer community have as many viable options for complying with this requirement. So we are testing with others as well. All right, so now we're going to talk about the OutBack solutions. So because different areas are enforcing different code cycles, it's quickly becoming confusing on what products you need for your area. So next, we're going to discuss the different options for these code cycles. And this is what I had included in the handout. So we have this nice flow chart here. So this flow chart describes OutBack Power solutions for the code cycle or application that is required. So we're going to go through this map here. So starting at the top left-hand corner here, or in the center here, we're going to ask this question, right? So is arc fault circuit detection interruption required, or are you in NEC code 2011 and later? So if the answer is no, then your solution will be for the FM80 will be the FlexWare PV4, PV6, and then for the FM100, it could be the FlexWare PV4. And with SkyBox, you don't need any additional hardware. If the answer is yes, then you have to ask yourself a different question. So is rapid shutdown or NEC 2014 and 2017 required? So if the answer is no, and we'll go over this a little again, a little bit more in depth. So if the answer is no, that essentially means that you need arc fault detection, but you do not need rapid shutdown. So this might be, for example, for ground-mounted systems. So we have for the FlexMax 1680, we have the FlexWare PV6 FH600 SDA. So this is the combiner box that you might see in the ICS Plus, also with a power supply. For the FlexMax 100, we have the same combiner box, but now with a generic power supply. And then with SkyBox, you don't need any additional products with SkyBox. It already has arc fault detection. Okay, so if rapid shutdown is needed, meaning you're in NEC 2014 and 2017, then which code cycle are you in? So if you're in 2014, for the FM80, the ICS Plus solution meets this requirement. For the FM100, we have a product called the RSD AFCI and meets this requirement with the FM100. And then for SkyBox, the SkyBox RSD-1 meets this requirement for the 2014 code cycle. All right, and then what we're going to be talking about more today is, so if you're in the 2017 code cycle, for the FM100, a module level rapid shutdown with the FlexWare PV6 SDA would be, this is the combiner box that you might see with the ICS Plus solution, would be the solution for this. So you'd have either a module level rapid shutdown along with the combiner box. And then for SkyBox, just a module level rapid shutdown would work. So we have the two products that we tested with, or the two companies that we tested with. So we tested with Tigo and IMO. So, so for the NEC 2017 cycle, you might notice there's not a FlexMax 60 or 80 option. And that's because it's a little expensive. And I'll talk about this later more in depth. So if you are installing a new installation, we highly recommend the FlexMax 100 overall, even more so with the NEC 2017. If you're really interested in just trying to incorporate the FlexMax 60 and 80 with rapid shutdown, feel free to contact OutBack Sales. I do believe our application also has that information as well, or some information about that, but we really do not recommend it. It's more expensive, and with the FlexMax 100, you get better performance, and overall the system cost would be lower. All right, so here we have a little bit, we have some diagrams that goes along with the solution. So we're going to essentially go over each of these options. So we'll have 4 different slides here. So first we're going to go over the arc fault detection and interruption is no. So if you don't need AFCI or rapid shutdown, you can simply use a combiner box with the FlexMax 60 and 80 and with the FlexMax 100. If it's possible, it is possible for the FlexMax 100 to have 2 strings and no combiner. So that is possible. It just depends on how you decide to configure your array and what modules you decide to use. The SkyBox configuration, you can have both strings go directly into the unit, so no additional hardware is necessary. Okay, so now if only arc fault detection and protection is required, so this is whether it's ground mounted or NEC 2011, then the FlexWare PV6 is so long FH600 SDA and the breaker control DC for the FlexMax 60 and 80. So if you need only arc fault, this is the bare minimum that you would need in order to meet that requirement with the FlexMax 60 and 80. For the FlexMax 100 or the FM100, you can use the the FlexWare PV6 SDA with a 24-volt power supply. So this is a power supply that's specific for the FlexMax 60 and 80. However, for the FlexMax 100, you can just use more of a generic power supply. There are some requirements for the power supply that are listed in the manuals, and we sell this power supply, so that just might be easier to buy it directly from us, but you don't have to use an OutBack specific power supply. And then for SkyBox, it has a built-in arc fault detection interruption, so no additional components are needed for arc fault. All right, so If you're in the NEC 2014 code cycle, that requires rapid shutdown and arc fault detection and protection. So with FlexMax 60 and 80, our ICS Plus is the solution. For the FlexMax 100, you can use the RSD AFCI. So the RSD AFCI, you can see the differences between the ICS Plus and the RSD AFCI. We don't have a remote trip breaker, and we also have the DC to DC converter. So this actually, the breaker control DC controls, this is a power supply that also controls this remote breaker and also communicates to the initiator. So this guy does 3 jobs, where here with the FlexMax 100, you don't really need that with this system. So it simplifies it quite a bit. And then finally, for SkyBox, the SkyBox RSD-1 is the solution. So this one looks very similar to the RSD AFCI, except it has dual contactors for the PV plus and PV minus. So SkyBox is a transformerless inverter, so both DC conductors aren't grounded. NEC 2014 states that the PV disconnecting means shall simultaneously disconnect all ungrounded supply conductors. So that's why we have 2 contactors in this version here. And then also note that the SkyBox combiner also does not come with arc fault, because SkyBox has arc fault detection within its unit. So the differences between these two would be the 2 contactors, and then also this one does not come with the arc fault. But they look very similar, so just wanted to point out the differences there. All right, so for NEC 2017 code cycle, like I said, we do not recommend the FM60 or 80 since it is a little expensive. We do recommend the FlexMax 100, and this is with the FlexWare PV6 FH600 SDA. So this is the same combiner box that you would see in the ICS Plus, along with a rapid or module level rapid shutdown solution. So we've tested with one of the products from Tigo, and then we have also tested with the IMOFire Raptor. And then with SkyBox, we have only the module level rapid shutdown is needed to meet the NEC 2017 requirement. And we've done testing with the IMOFire Raptor FRS-01 and then Tigo's TS4-S. Yeah, so. Okay, so that was a summary of our solutions depending on the code cycle that you're in or the application. Okay, so now we're going to talk about the communications portion of this. So we will review what is needed to communicate with OutBack products in order for the FM100 or SkyBox to perform a rapid shutdown and to ensure that there's no back voltage to the PV conductors. So we do have an application note that has more details on the NEC 2017 solutions. It's a guide for that, and it's available at outbackpower.com, and I will show you later live where you can find that. But no, I just want to also note that understanding this, although I think I would recommend that you would use products that we have tested just to make sure that it's going to work with our products. But really understanding that these concepts will help you integrate really any third-party products. But I highly recommend using products that we tested with. Okay, so for rapid shutdown with the FM100, you would use terminals 1 through 4, which is, you can see this here. All right, so terminals 1 and 2, they're common, and 3 or 4 are common. So you still need a rapid shutdown initiator or an outside source to initiate the rapid shutdown event. When the FM100 sees an open circuit between 1 and 3, or since these are common, it's really any yellow and purple terminal, then the FM100 will initiate its rapid shutdown sequence. When the FM100 sees a closed circuit or continuity, it will perform its normal function. And SkyBox, when we go over this next, will have the same functionality. So if you have multiple FM100s, then you will need to connect in parallel the multiple charge controllers using these extra terminals here. So you have 2 and 4 here. This means that they will all have to achieve a rapid shutdown condition. if one is not successful, which means it's the 30 volts within 30 seconds, if one is not successful, then it won't show a positive feedback that had successfully did a rapid shutdown. If you do not need rapid shutdown for an installation, then you would have to install a jumper between 1 and 3 or 2 and 4, just really one yellow terminal and one purple terminal. Because remember that a closed circuit means solar is on, so it's going to operate normally. An open circuit is a rapid shutdown event. So the FM100 will shut down if there's an open circuit here. So that's how. So that's essentially how the FM100 will receive its rapid shutdown signal. And you'll see we'll show this later too when we incorporate it as an entire system. Okay, so both SkyBox and FM100 uses continuity to determine when a rapid shutdown event has occurred. So an open circuit signals a rapid shutdown event and disables the SkyBox PV. A closed circuit signals to SkyBox that the solar should be on. So it's very similar to the FM100. So if no rapid shutdown is needed, then you'd have to put a jumper between terminals 4 and 12. And this is where it's located up here. All right, so we'll do a quick introduction to the two products that we will discuss today. And these are the products that we've tested with. Don't hesitate to visit their website and get more information about these third-party products. So yeah, so this is Tigo. So this is the TS4-S. There are 3 components involved with this system. So we have the CCA, which is the Cloud Connect Advanced. We have the TAP, and then we have the TS4-R-S or just -S. So the TS4-S, so it's this version here, you purchase this with the module. So it comes already integrated with each module. It's already installed. The TS4-R-S, this is a retrofit. So this you can install on any module that you already own, or that you might want to purchase separately that doesn't come with it. So this is a retrofit. So in most cases, I'm not sure which one you would get, but I will just simplify to the TS4-S when I talk about it, just so I don't have to say so many words. But essentially, you can either use the retrofit or you can purchase the module with it already. Okay, so the Cloud Connect Advanced, it receives a 24-volt input, and it has a wired connection to the tap. So there's a wired connection that connects to this tap here. So the tap receives a signal from the Cloud Connect Advanced. When the 24-volt power is disconnected from the CCA, that's when it does a rapid shutdown event. So that's what it's checking. It's checking, do I have 24 volts? Do I have 24 volts? And then once that 24 volts is removed, then it does a power or a rapid shutdown. And then from the tap to the actual for the actual module level power electronics, it communicates wirelessly to the TS4-S. And you essentially would have one of these on each module. But like I said, if you want more information, this is just a high-level summary, just so when I review the system, you kind of can see how things are connected and work together. But feel free, Tigo has ton of documentation on their products. Call them if you have questions on how their products work. This is just an overview. All right, so now we're going to do an introduction to the IMOFire Raptor, what components are involved here. So there are 2 main components. We have the Fire Raptor Rapid Shutdown -01, or the FRS-01. And then we also have the Emergency Rapid Shutdown Switch 1, or what we call the FRS-ESW1. It's very similar. So we'll go over this guy first, the FRS-01. This is what gets installed on possibly every module. I say possibly because you could technically, I'll talk about this in the next visual, but if each module is less than 40 volts, then you could technically connect 2 modules per one of these guys. So, but it just depends on your configuration, the modules you purchase, on whether you could do that or not. But and that's why you see it can power 20 to 40 modules. So this can power up to 20 FRSs. Oh, I didn't fix that. Okay, -01. This should say 01. It could power 20 to 40 modules. So that's this guy here. The switch has a power supply within it, and we'll talk about, you'll see that later as well. So this has a power supply in here. So this power supply that comes with this can power up to 20 of these FRSs -01. And depending on whether you have 2 modules or 1 module per FRS-01, you could do either 20 or 40 modules. It just depends on your on what your module specs are. Okay, so the FRS-01, so this has 3 inputs / outputs, 3 inputs. So we have the power. So this power comes from, this is the 24 volt DC that comes from this switch here. So this gets connected to this power in and out. This here is what connects to each module. So positive goes to positive, negative goes to negative. And then the STG stands for string, and this is what creates your strings. This is what connects your modules together. So yeah, so these are the main 2 components on this here. All right, so I kind of wanted to share this. So I found that most module level electronics assume a grid tie system. At least the documentation that I found so far, they might be changing that. So here is the IMOFire Raptor figure that describes how their system operates. So note that this is a grid tie configuration. It uses a string inverter. So we have the 2 products here. We have the FRS-01 that goes on every 2 modules, and it runs off 24 volts DC. So this actually has if you purchase this, you can purchase this with either, I believe it comes with the AC to DC converter. So that's why here it's connected to the AC side. You can use that green, or you can use a DC to DC converter too if you wish. But yeah, so this has an AC to DC converter. It converts your AC into 24 volts DC that's powering these, the FRS-01. All right, so here you can see that it goes on every 2 modules. And that's because the assumption is these modules are less than 40 volts, so that you have less than 80 volts even within these conductors here. All right, so this system would initiate a shutdown under 3 conditions. So it would do if the temperature exceeded 85 degrees Celsius, if there was a manual shutdown, meaning you have to press this button, or if there was a utility shutdown. And this is applicable for the grid tie inverter. So this shows, like I said, this shows 2 panels. Anyway, so this configuration is similar to actually what Tigo does too. So essentially, if you were to cut the power supply to the module level power electronics, this initiates a rapid shutdown. So whether it's the meter being pulled, initiates rapid shutdown. Whether you press the button, it's a rapid shutdown. But this is a string inverter. So let's look at what a battery-based system might look like. All right, so with our products, the string inverter is replaced with a charge controller or other battery-based unit. So instead of being fed by the grid, now you have 2 choices, because if you were to pull the meter on a battery-based system, you still could have AC output, and maybe you want the system to continue to run if the meter is pulled, if you have a backup panel. So it would shut down if the inverter if the temperature were to exceed 85 degrees Celsius, or if there were to be a manual shutdown. All right, so here here we have this being fed, this energy being fed essentially by the batteries. But you really have 2 choices in a battery-based system on how this is fed. So you could, or how this power is supplied. So you could choose either the battery, which we have shown here. So if this was the case, you would have a DC to DC converter inside here. right? Because you'd be converting essentially 48 volts if you had a 48 volt system to 24 volts. But you also have a second choice with a battery-based system. So you could also feed this by the inverter AC output. And if that was the case, this would look a little different, but you would use it's not shown here where this would connect. This shows a battery if you were to power this system with a battery. But if you were to power this with the AC output, then you would continue to use the AC to DC converter inside. Hopefully that wasn't too confusing. Essentially, you have options with a battery-based system, the battery or the AC output or the backup panel. All right. So what this means is that utility outage would not automatically initiate a rapid shutdown like you would see in a grid tie or string inverter. All right, so I do want to note, I said this before, we have an application note that has more details on the NEC 2017s, and we call it the NEC 2017 Solutions Guide. And it's available at outbackpower.com. I'll show you where to find it. So right now we're going to go over some examples. So these examples aren't the only products that could work with the SkyBox or FlexMax 100. These are just examples. These are just examples with ones that we've tested so far. So if you do have questions about the third-party products, please contact the third party that you have questions about. So we can only talk about products that we support and that we can only speak to products that we support. Okay. So, all right, so here we have, I was hesitant to show this, but this is just an example. We have an example of the FM6080 with NEC 2017. So if you take a look here, so this is with the IMOFire Raptor. If you take a look here, you can see that we have two completely separate systems. So you'd have to purchase an ICS Plus system, which we have here. So we have the combiner box, the RSI, the control power supply, and the remote trip breaker. So you have this system here, which is our NEC 2014 solution. And then you would also have to purchase a complete module level rapid shutdown solution. So it's a little pricey. We would highly recommend the FM100 instead. You get better performance, higher power, and less complexity if you were to go towards the FM100. So this is possible, but we do not recommend this type of solution. So here, notice that the IOMO products could go to either the battery, so we have here the battery, or the AC output as a source. We do not use the circuit breaker control. You cannot, in this configuration, we do not use this circuit breaker control to supply this as a DC-DC converter. So it has to be its own converter within its switch enclosure. So you'll see that in the next slide. So you can't use this. This has been designed for our products and has a specific startup sequence. So if you were to do this, you have to either connect this to the battery and use the AC or the DC to DC converter, or to the AC output and use the AC to DC converter. All right, so the takeaway here is that we recommend the FM100 over the FM80 with NEC 2017 rapid shutdown. So we do it for reduced system costs, reduced complexity, and increased performance. So we do not recommend this. And I think I do have this information in the application note, although we don't recommend it. So we'll see if we'll keep it or not, but we highly recommend the FM100. Okay, so here is the FM100, an example with the IMOFire Raptor with the NEC 2017. So remember, the FM100 uses continuity to determine when a rapid shutdown event has occurred. So an open circuit signals a rapid shutdown event and disables the FM100. And a closed circuit signals to the FM100 that the solar should be on. So this logic can be used to integrate third-party rapid shutdown devices. So you can use a dry contact or a relay with a dry contact to give proper signal to the FM100. With the IMOFire Raptor, The removal of the 24 volts from the FRS-01 will initiate a rapid shutdown. So the same 24 volts DC powering the FRS. So we have, this is our battery or our AC output. This is our converter, either a DC to DC or AC to DC. So when we remove this power here, it removes power to the FRS-01, which are these guys here. It removes this power, and it also removes power to this relay. So you could do a normally open relay. So when you remove power here, it gives that open signal to your FlexMax 100 that a rapid shutdown event has occurred. Simultaneously, it will give a signal to your module level rapid shutdown that a rapid shutdown has occurred. So the same 24 volts DC powering can be used to both give the signal to the FM100, give the signal to your combiner box, and also a signal to the FRS-01. All right, and then here we have this combiner box uses a 24 volts, so it seeks 24 volts. When it loses the 24 volt signal, it's very similar to the module level rapid shutdown. When it doesn't see the 24 volts, it opens up this contactor here and it initiates a rapid shutdown. So you have three signals going on. We have loss of 24 volts to your module level rapid to your FRS-01. You have a loss of 24 volts to your combiner box, and then you have your signaling an open circuit to your FM100. All right, so the FRS ESW, this guy here, this switch enclosure has a power converter within the enclosure. So you just need to connect it to a source. So it depends on which model you have. So it could be an AC to DC converter that you order, or the DC to DC converter. Okay, so here's an example of IMOFire Raptor solution for the SkyBox with the SkyBox. So this is a similar product. So SkyBox uses continuity, just like the FM100, to determine when a rapid shutdown event has occurred. An open circuit signals a rapid shutdown event and disables the PV output. So you can also, a little bit an extra side note, you can also program, if you like, for the SkyBox output to be disabled as well. That is programmable. That is not a requirement for now, at least that I know of, but that is programmable. So it definitely disables the SkyBox PV output. Possibly if you program it to do so, it can also disable the backup loads, the output as well. A closed circuit signals to the SkyBox that the solar should be on. This logic will be used to integrate third-party rapid shutdown devices. So with the IMOFire Raptor, just like previously, the removal of 24 volts DC from the FRS-01, which you'll see here, will initiate the rapid shutdown. So the same 24 volts powering the FRS-01 can be used to power a dry contact that can be used to signal to SkyBox as well. So yeah, and then here you can see we have you could use either an AC to DC or a DC to DC converter, and I have that shown here on the left hand side. This is the AC to DC converter that you can get from IMO, and then the power supply that you can get from us. All right, so now we're going to jump into Tigo examples. So remember, these are just examples. These are not the only way to do this. These are just examples of how you could do this. So here's a FM100 with the Tigo TS4S with NEC 2017 rapid shutdown. So the FM100, like I said, uses continuity to determine when a rapid shutdown event has occurred. An open circuit signal signals a rapid shutdown and disables the FM100. A closed circuit tells the FM100 everything's good, solar should be on, run as normal. So this logic should be used to integrate third-party shutdown devices, which we will do here. This one's a little bit, this is a different way to do it. So you can use a dry contact or a relay with a dry contact to give the proper signal to the FM100. In this example, however, we show a dual circuit switch where one circuit acts as a dry contact used to signal the FM100, and the other circuit is to remove power from the module level rapid shutdown, and also for the combiner box for a rapid shutdown event. So with the Tigo TS4S, the removal of 24 volts from the Cloud Connect Advance will initiate a rapid shutdown event. So here we have our 24 volts. So we have 24 volts here, we have our DC minus here. So you would be essentially removing power or providing power, removing power to the combiner box and also to the Cloud Connect Advance. And this, so removal 24 volts is signal to a rapid shutdown event. Let's see. Okay, so then here you can see that we have the power supply. We have this power supply here. We're using the DC to DC converter that is powering the 24 volts. And then you can either remove the 24 volts or supply the 24 volts. The Cloud Connect Advance is hardwired, has wires to the tap. This tap is on the roof near the devices. It has a certain range. I don't know that from the top of my head what the range is, but it has a certain range of how close it needs to be with these devices. And this talks wirelessly to each of these, each of the TS4-S. So this is how this type of system would operate. But the key thing for us is how do you communicate with our products, with these third-party products. So essentially 24 volts or 0 volts, and then open circuit, closed circuit. All right, so this is the example with SkyBox. So SkyBox uses continuity just like the previous examples. So here we have, again, that dual circuit switch. So this circuit is used to communicate to SkyBox whether there's a rapid shutdown event or not. While this circuit here is either providing or removing the 24 volts DC to the system. So this is this is very similar to the previous one, except in this example, we don't have a combiner box. Actually, yeah, in this example, we don't have a combiner box. So, so this simplifies it significantly as well, but very similar. It's interesting too, because the two products have very similar ways to implement rapid shutdown signal. So it's essentially 24 volts, and the removal of 24 volts rapid shutdown event. When you provide the 24 volts back, it operates as normal. So it's very interesting. Okay, so we're going to provide a little bit more information. All right, so like I said, we're continuing to do testing. Right, the information that I provided you today is applicable for today, but as we're doing more tests, I highly recommend going to our website and checking out what is new. We will be posting this video on YouTube, but if you're watching this on YouTube and it's a couple months from now, I would highly recommend going to our application note or finding some of our documentation, because things may have changed, we may have tested with more products. So I highly recommend that. So you can see we have some letters of compliance from Tigo, and that's provided on their website. You can find that on their website. We have the addresses where you can find these compliance letters as well. And then our safety compliance with the IMOFire Raptor is on our website, and I can show you where that is, hopefully. So I'll go over this with you live, but we're about to go to the website, and I'll show you where you can find these products. How you can find these products, what's there. We will also review, we do have the IMOFire Raptor also, so we are selling that, and you can find the documentation for the IMOFire Raptor on our website as well, and I'll show you where to find that. And this here contains data sheets, technical documentation, and the compliance letter. If you click into that. Okay. So we also have an application note that describes more in more detail about our products and the NAC 2017 Rapid Shutdown solution. And we have many other application notes too, if you're interested in learning more about different application notes, about AC coupling, etc. I don't want to bring that up. I don't want to talk about that. We're talking about Rapid Shutdown, but there's a lot of good application notes also coming out soon, so I would check that out. So like I said, this video is relevant for today, but in the future, the best place to get the latest information about our products as new products get tested and released would be on our website. Okay, and I will show you, okay, where all of this is. And then we'll be concluding. So if you have questions, go ahead and write them down. All right, so here we're at outbackpower.com. I like to go into installers. It seems like that has the most tabs. I don't think I've entered the owners or the other one. Okay, so the first thing that we're gonna go over is where to find our products on Rapid Shutdown. So you go to product tab here. There's one called safety compliance. I would just go to all safety compliance so you can see all of the products. So if you click on all safety compliance and then you scroll down, you can see where we have all of our solutions that we have talked about. So you can see that we have the RSD AFCI, which is our FlexMax 100 with NEC 2014. We have the SkyBox Rapid Shutdown solution with NEC 2014. We have the IMOFire Raptor. We also have our other combiner boxes, ICS Plus, FlexWare ICS, and the FlexWare PV. So this is where you can find information on all of our solutions. If we end up with more products, I would just click on, like I said, products, all safety compliance, and then you'll find a great summary of all the offerings that we have. So let's click into the IMOFire Raptor and see what's there. Okay, so here you can find the data sheet. You can find technical documentation, and then you can also find that compliance letter. And this applies to both the FM100 and the SkyBox about the product that we tested with these two, the FRS-01 with this product. So if you're interested, so this is where you can find more information about the IMOFire Raptor. So next we're gonna talk about the, so let's go back. We're gonna talk about the application notes. So we're gonna go back into installers. You didn't have to go back, but I'm just gonna start over. Okay, so then you go to resources. So under resources, you can go to product application notes and click on that. Okay, are we there? No. All right, and then we have this broken up into categories: inverter chargers, SkyBox, charge controllers, energy storage, system management, safety compliance, and pro harvest. So if you click onto safety compliance, you can find OutBack products with module level rapid shutdown. So as we test more products, we'll be updating this application note. So if you have any questions, those are the two places I would check. I would check the application note. I would also check the all safety compliance to see if there's a new product available. And Ian might have some feedback on that later too. So I think that's all on the website. Another great resource I love to plug is also, if you go to resources, is the user forum. So this user forum contains a lot of experienced installers that help each other out, especially when new regulations are coming up, or they're coming, they're talking to HJs or some applications. So it's a great resource to pick somebody's brain and maybe share some knowledge. We also, OutBack employees also go and chime in also when they have a chance to help out when they can. So it's full of experienced installers and OutBack employees. And I try to contribute when I can. So that's also a great resource. All right, I think I covered all of the website stuff. All right, well, my name is Gwendolyn Espy, and this is the NEC 2017 Rapid Shutdown with OutBack Products, module level rapid shutdown. We're gonna go to a Q&A session, but for those of you who have to go, I just wanna thank you so much for your time, and I hope that you found this helpful. Thank you.
Of course, this is Quinn Magic.